Okay, so for this section, we are learning the idea of a completing square. So before we learn the actual idea of complete square, so let's look at the concept of having a perfect square. So perfect squares, it looks something like this. So perfect squares will look something like ax plus b with a square. So it can be general anything with a square. Okay, so if you look at the three questions in these examples, all of them are in a perfect square format. So all of them are in a perfect square format. So when an equation is in this perfect square format, okay, you can solve it without expansion. You can solve it without expansion. So for example, what I will do, I will kind of take square roots on both sides. So in a way, you throw over the square, you will be achieving a square root. So when you've gotten the square root, okay, you should be having two answers. So there are two possible square roots. So in a way, there are two possible answers. That means, right, 2x minus 3 can be a 8, can be a positive 8, or 2x minus 3 can be a negative 8. Then you solve as per normal. So I solve it without doing the full expansion. So you might be thinking, what if I will prefer to expand? Well, if you prefer to expand, you will still get the right answer, except that it's a little bit longer. So if you prefer to expand out, you'll be getting something like this. So you got to bring everything over so that you can have equal to 0. So at this stage, you can try the factorizing. If you find the numbers too difficult to try factorizing, of course, you can use back your quadratic formula. So you can use back the quadratic formula with the ABC stated here. And you work out using the quadratic formula. If you try working out, the answer should be the same, but you will realize that it's quite long. You still got a lot of steps to go through. So when you got something that is in a perfect square form, so maybe taking square root can be a little bit faster. Okay, so this is the idea. So when it is in a perfect square format, we can solve it without expanding out. We can solve it by taking square roots on both sides. So you will get two possible answers. You can get a positive 4 or you can get a negative 4. So from here, you can get the two respective answers. So if you choose to open up, you should be getting the same answer. It shouldn't make sense that you get a different answer. So it's actually faster if you take a square root. So in this case, right, I'm also doing a square root. So meaning x minus 3 can be a positive square root, or x minus 3 can be a negative square root. Then you shift the 3 over. So in this case, you're not getting a very nice answer. So usually that's fine as well. If you're not getting a very nice answer, it's a chain of decimal. You go for 3SF or the accuracy stated in the question. So for O-level question, if the accuracy is not stated, it is always 3SF. Unless the accuracy can be 2 dp, it should be stated in the question. So in example 8, I'm trying to show you if you have a perfect square equal to in this format, instead of expanding out, it will be faster if you have taken a square root. You take a positive and negative square root. But it will still work if you still prefer to expand it out. So you can try the idea, but we go for the shorter one during exam because it saves the time and it saves the exposure for careless mistake.